Hello, hi everyone. For those who are early, maybe you can visit our Google Colab worksheet on your web browser. Just type this URL and remember to save a copy to your Google Drive because it's a read-only worksheet. Now the URL is also on the chat, so yep. Yep. Okay, it's 10 o'clock now. Yeah, so welcome everyone to our final workshop with NUS Hackers and NUS Statistics and Data Science Club. Yeah, so this workshop will be on data visualization in Python and Tableau. But before that, let me off the background music. Okay. Okay. So during this workshop, if you have any questions, we will respond to your questions live on Slido. So do join us at Slido. You can scan the QR code and type your questions in any point of time you have any questions with regards to the content. Okay, maybe I'll give you all like 10 seconds. Yeah. Okay, can. Okay, so for today, we'll be using Google Colab as with other workshops. So if you haven't yet, the Google Colab URL is actually on the chat. So please refer to the chat if to access the participant version. And the slides, this slide and the solutions, recommended solutions will be provided at the very end of the session. Okay. So as we said, today is the very last workshop of NUS Hackers X NUS Statistics and Data Science Society workshop. So at the first lesson, we learned about, at the first workshop, we learned about introduction to Python. I hope most of you have learned the basics, the fundamental of how to program in Python from that workshop. Then after that, we move forward to automation with Python, where we learn about how to download certain content from online and some other very cool features that we can do using Python to automate our workflow. And last week, we had our NumPy and Pandas, where we learned about data manipulation. And today will be a follow-up of the previous workshop, which is talking about data visualization. I know some of you may not have attended the previous week's workshop, but fret not, it will just be a very, I mean, it won't really heavily rely on NumPy and Pandas, so do not worry. Okay. Okay. So I think for most of you, you're a repeated visitor to Hackerschool. So the objective of Hackerschool is actually to get you started on building your own programs, building your own projects. So getting started on programming and making stuff so that actually you have a project that you can call your own. So just a gentle reminder, we are not a coding boot camp, to make you a professional coder, but it's actually an interactive online workshop where we teach you, where we allow you to learn how to learn by yourself. Okay, so moving on, we have, that means after this session, we have introduction to modern JavaScript. We have HTML and CSS, as well as React. So they are more of the web development side of it. Yep. So after this week, do feel free to join us if you are interested in learning more about web development. Okay. then maybe pass the time to SDS.
Yes. Okay. Thank you, Chun Yong. So we're from SDS. So we're working together with NUS Hackers for this particular workshop. So who are we exactly as SDS? Basically, we are just a society of people who are really interested in data science and statistics, and we aim to bring together people with a similar interests so that we can pursue even deeper topics, deeper learning into this field, like deep learning. So we do host a lot of workshops, and we even have like summer learning programs, like our study sessions on deep learning and stuff like that. And then other than that, we also have like career planning. We do like resume workshops and stuff. Yeah. So basically, we're just a group of people who really love stats and we like to pursue our interests here. Yeah. Okay, maybe a bit more about the instructors for today. Like the four of us, we have along with me. Okay, I'm Edmund. I'm year 3 BZA. We have Madi, Shreya, and Triyong. Yeah, maybe you want to introduce yourselves, Madi.
Yeah. Hi, I'm Madi. I'm a year 1 GSA from NUS SDS. I'll be walking through with you the code alongs for today.
Hi, I'm Shreya, year 3 data science as well. I will be going through Tableau.
Oh, me. Okay. Yeah, so I'm Chun Yong. I'll be bringing through the introduction as well as the overview of data visualization. So I'm studying computer science and statistics from NUS Hackers. Okay, so what's the objective of today's workshop? As we know, data visualization is a very big sort of idea, and we won't be able to cover everything today. So today we are just covering the basics. So we're going to describe the importance of data visualization for day-to-day decision making, analyze some good design principles when you present your data, and of course use visuals to convey relationships between variables clearly, as well as create interesting graphs and dashboards. So today, not only will you learn how to create graphs using Python, we also will be exploring how to make full dashboards where it's just a combination of different graphs in order to present a whole full picture to our audience. And lastly, we also recognize that after or beyond Python, there are also third-party programs which are very powerful and very useful for data visualization, like Excel and Tableau. Okay, so managing expectations. First, we won't be covering all the libraries in Python for visualization. As you will see later, there are one whole long list of libraries, and of course, not every library may be suitable for us. We also won't be going through the pre-visualization cleaning. It's a very long process. So data visualization is more than just typing code on the computer, like dot plot, and it will get you the plot directly. Because most of the time, the data might not be clean, might not be 100% what we actually need. So we have to clean it first. So it's a very long drawn process. Today, we will only focus on handling already clean data. And lastly, do not expect to take up a certification course after this workshop, unless you have money to spare. Yeah, actually it's a legit thing. Yeah, you can get certified in Tableau, but we won't get into that details lah. Okay, so today's workshop content will be quite a lot. So first we will be covering the overview, what is data visualization all about. Then we will investigate how we can use Python and Tableau to how we can use Python to visualize different type of graphs, as well as give a short intro to Tableau. Okay, first, overview of data visualization. Okay, so what is data visualization? I think most of you, it's basically quite intuitive, is visualizing data, right? So it's a graphical representation of information and data. And I think why data visualization is so important is because just using NumPy and Pandas, you'll just get a data frame. And presenting your data frame to your audience isn't really very helpful because it's just like a table. But what insights can you get from that data frame or that table? And what kind of visuals can you create? Or what message do you want to convey? I think that is way more important. So the use of visual elements such as charts, like bar charts, graphs, line graphs, data visualization allows us to understand some trends and patterns in data. And of course, is storytelling with a purpose. Okay, so now we will have a few examples to show, and you'll type in the chat whether is it a good example or a bad example. Okay, first one. Okay, so maybe yeah, all of you can type in the chat. Is this a good example or data visualization or not? Give you all 5 seconds. Okay, I see one person say good. Yeah, maybe some of you can also like explain why is it bad? Why is it bad? Yeah. Okay, the number don't match. Yeah, so as you see, right, this one is just 33%. So basically it's 1/3, and no is like 67%. But you see, it's like flip. So actually it's not representative, right? So if you just see in one glance, you'll be like, oh yes, it's actually more. But actually when you verify the number, it doesn't match. So it gives a very like, yeah, what kind of message is this trying to present, right? It's two opposite message. Okay, next. So we see this graphics by Fox News, very reliable news channel. So yeah, so is this a good example or a bad example? Yeah. Yeah. Then maybe you can share your reasons also. Like why is it bad? Okay, I hear not proportional. Yeah. So you see, right? Like the difference between people on welfare and people full-time with job. Maybe I can annotate. Yeah, here, right? The difference is, I don't know, about 7 million. But you see here, it's like what? 100 million. So it's not even proportional. So the sad fact is actually there are quite a lot of visualizations that use this kind of visual trick to sort of exaggerate their data. But actually the difference is not a lot. It's more or less equal when you look at it. Yeah. Okay, last one. New cases per day. Okay, this one I think is a bit difficult to spot. So extra points, bonus points if you can spot it. Yeah. Is it a good or bad example? Oh, one person spot it. Oh, okay. That's very good. That's very good. So for those who can't see it, so you see here it's like 400 and 350. So the difference is 50. Here so the difference is 50. But when you look further, this one the difference is 10. So it's very inconsistent. So the negative thing about it is when it's inconsistent, it might look like you're trying to force the graph to fit a certain shape that you want it to look like. So for here is a upward shape. Yeah. And I think personally for me, I wouldn't put the number here because I mean you have the axis for a very good reason, right? So you can sort of match it. Yeah. So I think for me, if I would like to present my graph, I'll use a X or a smaller circle so that actually they can identify, you know, like where does it match? Because if it's a very big circle, right, then it's like, you know, yeah, if it's a very big circle, then where does it lie? You know, I have to go and infer. Yeah, so it's all about clarity also. Yeah, are they trying to downplay the spike? I guess, yeah. Is it? Oh wait, what here, right? Yeah. Okay, so maybe now I will share with you a sort of good example that I found online. Wait, oh no, wait. A good example that I found. Yeah, so actually this is a dashboard that I've seen on COVID-19 in Singapore. So we can see, I think this, can you all see my screen? I think can, right? Yeah. So as we see, this is the number of COVID-19 cases, Singapore, new cases. Yeah. So we can see that the blue graph, the blue bar chart is actually the number of reported COVID-19 cases. And the green is the number of recovered COVID-19 patients. So these are statistics that are already given to us, for example, by the gov.sg Telegram chat. So what the maker of this dashboard did with it is they actually calculated the difference. So the number of reported minus the number of recovered patients to look at the change. So they plot this change as a cumulative graph. So we can be able to see what is the total number of active cases in Singapore. Right. So currently they are still having COVID, is reported but not recovered yet. So I think this is a very good example of good data visualization. So building on what we have now and generating useful insights. Okay. Okay. So the moral of the story is graphs are very powerful. In presenting it in one way might be very effective, and presenting it in another way might be very misleading. So graphs are very powerful, and we should know that there are some principles we should follow when we do data visualization. Okay. Okay. So now let's share. There are different tools that we have in the market. So we have Python, which I'm sure all of you have been using in the workshop so far. And we also have Tableau. Yeah, so we'll be introducing Tableau later. We also have R, which I know for those of you who are learning statistics, you are using it on for your intro mods. Yeah, there's Excel. For those of you taking GA 1000 or GR 1000, you'll be using Excel and Power BI. So what about for Python? So we have Matplotlib, Seaborn, Plotly, and even for R, there's like quite a lot of libraries like ggplot. Okay, so now the question is, since Python has so many libraries, which library do we use? Do we use Matplotlib? Do we use Seaborn, or do we use Plotly? Yeah, so we will explore this in our Google Colab. Okay, so head on to our Google Colab and follow us. Okay, can give 10 seconds to transition to the Google Colab. Okay. Okay, can. Okay, so for the first part of our Google Colab, we will explore the difference between, or explore how does Matplotlib, Seaborn, and Plotly help us with data visualization. So we know that clear and effective data visualization is very important to optimize your ability to convey your findings. There are different libraries, and so let's explore how are they different, what are their pros and cons. Okay, so first, let's import our tree library. Oh no, wait, sorry. First, save a copy. Okay, guys, remember to save a copy. Okay. Yep. Okay, so first, let's import. So the beautiful thing about Matplotlib is actually included in your Python library. So when you import pandas, it actually already has Matplotlib in it. Nani? Oh, sorry. Yeah, so we are playing with Matplotlib, Seaborn, and Plotly Express. Okay. So similar to last week, we will use the COVID-19 dataset. This week is actually the full dataset. So yeah, with all the columns and everything, but it shouldn't affect us a lot lah. Okay, so we have a mission right now. The Minister of Health has recruited you, us, to investigate the changes in total COVID-19 cases in Singapore over time. Okay, so the first thing we do is to reduce our sample space. Okay, so from our data frame, we are only going to filter to Singapore, to the cases which are in Singapore. Okay. Then next, we are going to calculate the 7-day average data. Okay, because our whole main goal is to make it look like the, do you know the Google, the COVID-19 cases? Yeah, later you'll see an example of that. Okay, so this is a useful statistics to us. This is this is an example of statistics that isn't really given to us yet, but we can calculate from our existing statistics, which is useful lah. Okay, so now we have prepared our data frame, but the question is, how do you sort of plot it? All right. Okay, so the trick is to use Matplotlib is very simple. All you need to do is you just add dot plot to your data frame. Okay, so dot plot. Okay, wait, before that, I'll show you without dot plot. Okay, this is the whole big data set. But if you add dot plot, you will be able to use Matplotlib. Oh, okay. So now we see that it's actually, there's a lot of things. And if you want to present this graph, it doesn't actually make a lot of sense because as you see, there is a lot of different things that they are plotting at once, right? And some of the columns, I don't think they are able to be plot also, like they are not numerical data. Okay, so that's very confusing. Actually, we don't need that much information, right? So let's filter the data set to only include the columns that we need. Okay, so from the challenge that we have, what is the 2 columns that we need? First, we need the total number of cases, the total. Okay, maybe I can write here first. First, we need the date, right? Because over time. Second, we need the total number of cases, new cases, right? And if we see in the column, okay, if we see in the column, there is date and there is new cases, okay? So let's see, so which one do we put first? So we know that date, we want to create a time series, right? So for date, we can put as our x-axis. Our new cases, we can put as our y-axis, okay? And in addition to plot, I put bar here. So what does it mean? I think it's very intuitive, right? So it's a bar plot. Okay, loading. Okay, so now we see this. But we see, how come our x-axis is like that one? Right? But okay, so that's much better than before, right? Now we actually can see something, right? But what if I wish to modify my chart? So what we can do is add additional parameters to specify the chart design. Okay, so let's do this. So we know our x-axis is date, our y-axis is new cases. So what do we want our title to be? What should our title be? Since it's new cases, right? We can put new cases in Singapore. Oh, sorry, in Singapore. Okay, so what we see is that now our x-axis have the word date, but our y-axis, we don't have a label for it, right? The only label is here in new case, but we want to make our graph as easy to understand as possible. So we will change the x label and the y label. Okay, so x label is basically the label for x-axis, y label is the label for the y-axis. Okay, so our x label, we have date, y label, we put number of cases. Okay, or for clarity, number of new cases. Okay, and figure size just means how big you want your graph to be. Okay, processing. Oh, okay. So what's the difference you see? We see that we have compared to this graph, we have a title, we have y-axis, our y label, our x label, and our graph is bigger. I mean our figure is bigger. Then we have changed the color to cyan color, but we see, wow, not helpful. You see our y-axis is all jumbled up. I kind of understand what's happening, right? And just for completeness sake, we will, okay, I forget the command for this already. Okay, we will add the 7-day average line. Whoop. Okay, so AX means that you are going to plot it on the same axis. So we are going to have a line plot on the same axis as this bar plot. So this is how you combine 2 graphs together. Okay, so now we see we have a 7-day average line, which is closer to what we want. But we see that it's very tedious to manually specify each and every setting, like the X label, Y label, almost everything. If we want to make more complex graph, it will be way longer. So can we do better? Right, that's the tagline. So yes, Seaborn make our life easier. So what is Seaborn? Seaborn is actually a high-level interface of Matplotlib. So we see that using we can use Matplotlib just by adding dot plot to your pandas data frame. So that's very convenient. But there are other libraries that we have to import, but can make our life simpler. Okay, so let's replicate the same thing using Seaborn. Okay. Yep. So so using Seaborn, what we do is, yeah, so our data now is, actually we can follow this format. We realize that this format is actually standardized for quite a lot of the libraries. So we don't have to change the format. If you can recognize this format, actually it's good enough. Okay, so our data is df.singapore. And here we can add our column data, date, new cases, color sign. We can set the title, new cases in Singapore. Axis. Okay, we'll have a line plot, date, average, 7 days, new cases. Okay, hopefully you can use this. Oh, sorry. Okay, so to use Seaborn, actually, we realize we require matplotlib to import matplotlib. Okay, so this sort of a limitation of Seaborn. Seaborn actually builds on matplotlib, but we see that if we want to really further use Seaborn, we have to rely back on matplotlib. But we'll see there's a difference. Okay, so what does this mean? This means we are creating a bar plot using Seaborn, and a beautiful part of it is, that it seems a bit more intuitive than matplotlib. I mean, this is a very small example, so we cannot see it. But for bigger examples, we will see that it's slightly more intuitive. Set title, then we will have a line plot that is plotting on the axis as the new cases. Okay, so we see that we have our Y label, our X label, our title, and we have a graph like this, which is very similar to what we have here. Technically, it's supposed to be intuitive, but I think your mileage may vary. For bigger projects, definitely the number of lines will be much less. Okay, so that's slightly simpler, but there still needs to iron out. We see that this date doesn't have the format we want here. So this is, so like our number of new cases, but here we just have new cases. Why? Because it's following the column name. Okay, so there's still some minor details to iron out. So we learned that matplotlib and Seaborn may be the most commonly used data visualization packet, or a few of the most commonly used Data Viz package. Some of it only. But there's a simpler method that produces superior graph than either of these. So now we'll introduce you to Plotly. Okay, so let's discover the amazing part of Plotly right now. Okay, so the Plotly Express has this format. So the chart type, data frame, x-axis, y-axis, which is exactly, or more or less exactly the same as Seaborn. Okay, so first one, data frame, Singapore. X-axis, date. Y-axis, new case. What title should we have? New cases in Singapore. Okay, so actually we see that this format is quite intuitive. What is your data frame? What column do you want to represent your x-axis? What column do you want to represent your y-axis? And what's the title you want? Actually, this is optional. Okay, so add scatter means we want to add on to the previous graph. Okay, so the mode is we want a line graph. X-axis, we need date. So notice that actually this style is different from here, right? So here we need to identify the data frame, then add the column name. But here we add the Panda series altogether. Okay. Average 7 days. Okay, very good. So can you visualize what will this give us? This will give us a bar plot of the new cases, changes in new cases over time, and we will add a 7-day average line. Okay, wow. Okay, so now we see that we can finally see our date. All right, we can finally see our date. And definitely we can still change our x-axis, y-axis, but we have to add additional parameters. Okay, so what's the beautiful thing of Plotly? Why am I showing this? Can't we just do the same thing? we notice that actually there's this very nice toolbar on top where we can save this plot as a PNG. We can zoom in. So for example, we can zoom in. We can drag, say, oh, I want to see this. We can zoom in, right? Then if you want to reset, we can reset. So for example, we want to see, oh, COVID-19 cases is very high right now. Now it's 900. I don't think this data set is actually include the latest data set, but we can see, oh, for 2021, it's actually going up, right? And what else do we have? We have pen, right? We have zoom in, zoom in, zoom out, auto scale, spike line. So the good thing about spike line is, for example, or we can hover and see, oh, what's the number of new cases, right? But with spike lines, we can have a improved sort of a visualization where we can look, at what point it touches the y-axis. Okay, so we see that this is a much upgraded form because we can just hover at each data point and find out, oh, what is the specific information about that data point. Okay, so it's a much upgraded version. If you don't like the 7-day average line, you can just press this to disable it. If you want it back, you can have it back. Okay, so now we see that there's a lot of possibilities with this. We have very powerful options like zoom in, zoom out, save as an image, hover over data, and a lot more. If you want to do this using Matplotlib and Seaborn, some may be possible, but it will be very tedious, and others might just be straight out impossible. Like maybe saving as PNG. Okay, I'm not sure whether we can do that using Matplotlib or Seaborn using code. So the moral of the story is Matplotlib, Seaborn, and Plotly are 3 different data visualization libraries that can create visually appealing graphs. But Plotly allows for a lot of different customization options and interactivity with a very fairly intuitive syntax. So today, the good news is today, a lot of I think companies are using, or a lot of projects are using Plotly Express. In my previous internship, I used Plotly Express almost every single day. Yeah, so I think it's a very cool tool to learn and use. Okay, so yeah, so now I'll finish my part and I'll hand over the time to Emma.
All right, okay, thank you, Chen Yong. Okay, let me share my screen. All right, so thank you, Chen Yong, for the very detailed comparison between the 3 common libraries we see today. So I'm sure some of you have used like Matplotlib, Seaborn in some of your modules maybe. So yeah, for today, we'll be focusing on Plotly because we find Plotly the most intuitive of the 3, and you can see there's so much potential in all the functions you can do. Okay, so if you like a more detailed article on these 3, you can just scan this QR code and it'll bring you to a very nice article by Towards Data Science. Okay, so if some of you might be a bit confused, if like some of you are new to data visualization, new to coding, and couldn't really keep up with the demo, no worries, because now we'll be going through the basics of data visualization. So just now was just a comparison between the 3 libraries. So now we'll be going into the basics, so zooming in. Okay, so for today's workshop, how we're going to structure it is we're going to structure it by 5 different objectives. So we're going to visualize amounts, we're going to visualize proportions, we're going to visualize geospatial data, distributions, and after that relationships. So it's going to be quite a journey today. So if you have any questions, please do slide into our Slido and we will answer them in due time. So, or you can just ask in the Zoom chat also. Yep, so we'll be zooming right in to the first one, which is amounts. So when we talk about amounts, we usually think of stuff like comparing between categories. So categories are stuff like different genres of items, different categories of items. For example, you can plot if you're going to talk about a single category, you can plot bars, like bar charts, horizontal or vertically, or even a dot plot, which I'll be covering later a bit more. Then if you want to compare a few more categories, you can, of course, group the bars together. So a bit more into bar plots. I'm sure this is a very common plot. Everyone's seen this before. So we're going to compare different categories using this. So you can see here, categories can be like movie titles. It can be like age groups. It can even be like different types of organizations up here. So you can look, if you look at the bottom one, you can see if you're comparing the different grossing of movies, you can see that Star Wars from this plot, you can easily see that Star Wars is the highest grossing. So yeah, it's a very nice plot to be able to compare different categories. Yeah, or if you're talking about even more categories, you can look at group and stacked bar charts. So if you look at the bottom left, you can see that there's you're visualizing median income against age, when you're having a further subdividing of races between like Asian, white, Hispanic, and Black. So for each age group, you can see like you can compare the median income of the different groups. Yep. So this is one good thing about group charts. Then you can look at the stacked bar charts here. It's a very nice example from the Titanic data set. So you can see the different class passengers. These are your cabin classes. So it's like first class cabin, all the way to third class cabin. You can see that the breakdown of genders at that point of time. So you can see, you can compare, and you can see that, like for example, in the third class cabin, there's 499 male passengers, 212 female passengers. You can see immediately that there are more male passengers than female passengers in the third class on Titanic. Yeah. Okay. So now it's a plot that's a little bit rarer, but probably you've seen it in the newspaper some days. So these are this plot actually compares values that do not need to start from 0. So over here, you're not looking at proportions, you're discounting proportions altogether. You're just merely looking and comparing at different values. Like for example, here, life expectancy against different countries. So you can see that immediately Canada on top, and with the highest life expectancy of 80 plus. Then over here, you can see that maybe Haiti is about 60 plus. And then from here, we can want to do some further investigations into why there's such a trend. Yep, then you can see that if you sort it nicely according to life expectancy, you can get this easy to read plot. Yep. So another one that's pretty cool is a heat map. So this heat map actually can visualize quantities and highlight broader trends. So you can see over here, this is the internet adoption over time. So for lighter color represents more people. There's like more internet users, the higher density of people. And then a black, like a darker color, actually represents fewer. So you can immediately see from this plot that the country on the top of the plot has the fastest advancement in internet users. So you can see that they went from dark color to light color really quick, like in the mid 2000, between 2000 and 2005. Then if you look at the bottom of the plot, you can see that there are countries who are a bit slower in internet adoption. So see that maybe in Kenya, it's slightly slower. Yeah. So you can see a trend just from one glance. All right, so that's for visualizing amounts as a brief intro. So now Mahdi will take us through a code along to plot some of these plots based on the COVID data set. Hey, Mahdi, on to you.
Yep, thank you, Edmund. Yep, so hope everyone has been enjoying the workshop so far. So we'll be using Plotly as mentioned earlier, and it is an up and coming library. I know many of you have like some confusion of which library to use, but as a data scientist or as a data analyst or business analyst, you all have to like master one of the tools that helps you to visualize. And I'm sure Plotly plays an important role because of its appealing plots that you have already seen from the examples above. You don't really have to manipulate your CSS or your styling to make it look really appealing as compared to other like Matplotlib. So as an coming library, I would recommend you to like work with Plotly, and it can be also easily deployed, and dashboard can be simply made, which we'll see through the code alongs later. So if you want to get more information on Plotly, just click on the link and just check the official docs. So let us just import the relevant libraries. I'm sure some of you have already done it above. So the data set we have been using is downloaded from Kaggle, can be downloaded here as well. And we won't be really cleaning the data, as it will undermine the main objective of this workshop. So for those who have been looking at the different columns, try to draw insights from how each of the columns can relate to the or each of the columns relate to each other, and try to tell a story. So for example, let us just look at what the data says. So df.head would just give us a small data frame of 5 rows, but this particular data set has got a lot of columns. So a better way to look at it would be through df.info. And we have got so many columns, and some of the columns are really familiar to us through the COVID-19, like the new cases and total cases and deaths. But probably there are some other information like stringency index, the poverty, human development index. As a data analyst, you try to be very inquisitive and ask many questions on how such columns can actually find any trend to our data. So we see if there's any correlation between like human development index and the COVID-19 cases or deaths. That would be really such an insightful data that you present to your team. Yeah. So that I'll leave you all to explore the data on your free time. So the data is actually quite unclean. So you might have to pull in some of the skills from last week and today's skills to put in a really nice dashboard that, like, for example, Chun Yong showed earlier. And let us just filter out 3 main data frames which help us to visualize the data. So for the first part, when visualizing amounts, we'll look at bar plots. So when we are posed with a new library, right, we always look at the documentation for help. So let us just look at what the Plotly bar charts tell us. So you can see that the official document allows shows some examples of how the bar chart is done using the Plotly Express. Well, Plotly Express is a really fast way to get the charts out, and also there are some other options of stacking the bar charts. And also this is something called Dash, which is coupled with Plotly, and it will allow for user interaction. For example, you have a drop down here, and the user puts in a new data, and the plot will change accordingly. So this is how you can build a dashboard, but that comes together with Dash. We will keep all that to a minimal, and there are some other customizations as well, like the color gradient. And we also have so there was actually a plot on the horizontal plot as well. So we will just leave it to you to explore the official documentation. And another documentation that is important would be the API reference stocks. So when you have a specific bar function that you would like to apply, you want to know what are all the parameters and arguments that are available. So you can see that you have a different arguments. For example, we have shown the data frame X and Y that were the commonly used ones. But if you would like to change some of the calculations, or for example, the color range, you can look at what are the correct data inputs, the correct data type. Is it a string or integer, or can it be a column? And then from there, you can manipulate your data to make it look even nicer. So these are all documentation that is available. So you'll leave it to explore. And first, let us just look at a specific example of px.bar. So bar chart, we'll be using the df world. And let us look at, for example, the dates versus the total cases in the whole world. And let us just run this. Cool. We have got a really nice plot, and we have got the axis with the title and also the marks label for both the X and the Y. But what else do you think is actually missing here? I'm sure many of you have guessed that probably a title would make it look better. So let us just include a title argument to make it better. So let us run this now. Cool. Now we have got a total cases of COVID-19 around the world. But are you actually able to see any bars here? No, for myself, I'm just seeing a whole sea of blue. So let us probably use this feature of zooming in, using just drag your cursor around a specific range, and then probably just zoom in. Oh, now you can actually see the individual bars on a specific date. So for example, December 27, you can see the total cases, and you can predict the trend from this plot that is actually rising throughout the days. And there are other features available here, like resetting, zooming in, and you can save the plot as a PNG as well. So that is why we told that Plotly is a really interactive platform and a library to use. So, but it's actually quite hard for the user to zoom in and out every time using this particular cursor method. So let us probably use an update axis method to draw a range slider. So let us just look at how it looks like first for explaining. So this range slider allows the user to zoom in and out of a specific date range by having this just below the x-axis. It's more intuitive and natural to have this slider when you have a date range is really long. So if you want the users to zoom into a specific date range, they will be able to you do it so with this slider. So that is pretty much with the px dot bar. So for the next few plots, we'll go through it quickly, fast, and so that go through. I'll skip the details. We can reference the docs for customization. So next we have the group bars. So as Edmund mentioned earlier, you can place two particular categories side by side. So let us just look at how this looks like. So here we are actually not using the Plotly Express method. That is the reason why, is because of using Plotly Express, we are only able to plot things quite fast, but with the graph object, we'll be able to do a lot of customization. So for example, this particular plot, if you zoom it in here, you would be able to see the Singapore data as well as the Malaysian data stacked side by side for each of the dates. So for Plotly Express, we only were able to pass in one data frame, but with the graph object, it will have this go dot bar, and then we will pass in the specific data frames, and then we will put this is using the group method. So the update layout allows you to customize the bars and how they should look like. So from these, we will be able to see the trend in the total cases for Singapore and Malaysia for every single day. So as you can see, after a certain while, Singapore's data was like quite stagnant, but Malaysia's data kept growing. Yeah. And next up, we have the stacked bars. So stacked bar is similar, but just that we have this change it the bar mode from bar stack from group to stack. So when you zoom in the data, you'll be able to look at how the data is being stacked one on top of another. So we have got Singapore's data on top. That is because of the what's it called, the order that you have mentioned here in this graph object. This is actually tells a proportion as well, which we'll look into in a later part. So as you can see, you'll be able to see the amounts separately by just hovering over for each of the days. You can see how much Singapore or Malaysia have contributed individually to a total number of cases as a whole. And another thing that I'd like to mention is about the legend. So the first px.bar plot, we didn't need a legend because we were just talking about DF world. But now we have got Singapore and Malaysia, and the Plotly automatically assigns a color to the data frame, which we will be able to customize as well. But let us just be happy with this red and blue. And next we have this dot plot as well. So dot plot is actually similar to the bar chart, but the difference is that it's a horizontal bar chart, but we will remove the whole lot of area that was below. So for example, if a bar chart is drawn, you just have to have a rectangle from the start of the y-axis till this particular point here. But we will remove that we're using this dot plot method, so which is just a scatter method, but when you present it, the name is a dot plot, and we would have these dots aligned nicely. Do not worry about this manipulation of the data that we have mentioned here. We have already told that that's not the objective of this, and therefore let us just continue with what the data frame is being provided and just focus on the plotly method. And now it looks really nice, but if you were to have many rectangles stacked up in a horizontal way, it would look really cluttered. So that is why dot plot methods are really nice and intuitive, in the sense that you don't even have to start from zero, and people will be able to understand what your graph is talking about. Okay, let us just have a last plot before we go to the exercise. And heat maps. Heat maps, basically we are replacing colors with numbers. But for this, we would not be using Plotly, as Plotly's heat maps need some customization. So for this, we'll just go with Seaborn, because you just need to provide the name of the data frame, and it will automatically generate the plot for you. As you can see here, you can see the heat map showing the trend of the new COVID-19 cases. So the white area, or the white color that you're seeing here, is only null values. So as mentioned earlier, we're not focusing on the cleaning of the data, but there are some countries where you have data for every single month, for example, Spain, and you look with the color gradient, the concentration that is changing, right? So the darker color means there are lesser cases, and then it goes on to a lighter color here. For example, in the middle of the 2021 in Spain, you have got quite a number of cases, probably more than 80K, 800K. So that is why you can see that the color has changed throughout, and then from there it has gone down again. So this, you do not have to specify if the user doesn't want to see the numbers, or probably just see a trend, right? This color gradient can help, and this is why heat maps are used. You can see a correlation for different countries, and using you can see a correlation for multiple countries at the same time, using nice colors and representation. So now let us just apply one of the particular plot here, which is the stacked bar chart. So I'll just give about 1 minute. So because you can just use the code above for the stack bar chart. And yes, let us try, and I'll go through this after 1 minute. Thank you. Yep. So I hope everyone has tried out the plots. It's really easy. You just have to use the same code above of the go.bar, where we have the bar mode applied. So let us just put in the correct column. So we want the vaccination rates for Malaysia as well as Singapore. So we have the specific data frames. And for the x-axis, we just leave it to date. And for the y, we choose the people vaccinated. Okay. And then what is the bar mode that we would like to have? So the bar mode is the stack bar chart. So we're using the bar mode as stack as well. And we provide a title to this plot and let us just run fix stack. Cool. Now we have got this stack bar chart. You have noticed something that Singapore data is not provided on a daily basis. So on specific dates, you'll actually see the vaccination trends or the people vaccinated contribution to the total vaccination as a whole. So, but for Malaysia, you have actually got vaccination numbers for every single day. Yeah. So with that, I'll just pass the time back to Edmund. We'll continue on with the next section.
All right. Okay. Thank you so much for the very insightful demo of distribution. Visualizing amounts. Okay. So now we're moving on. I'll be sharing my screen. So after amounts, we'll be moving on to our next objective of today's workshop. So we'll be visualizing distributions now. So when we talk about distributions, you might think of stuff like histograms, density plots. So yes, those are exactly what we're going to cover today. So it's basically how we're going to distribute data across a certain dimension, can be time, can be age group. So with this, you can easily see the shape of the distribution. Maybe you can get some insights from there. Perhaps a certain dimension is skewed towards one direction, or you can see that it's very concentrated at a certain point. So one way you can look at it is like through a histogram. So we can see here it's a count against age histogram of the Titanic passengers. So this looks like a bar plot. It honestly is a bar plot, but instead of sorting it by like the height of the bars, we actually just leave it as it is, as its dimension. So in this plot, you can see that most passengers, they are concentrated between the ages of about 20, 30. So about these two are the highest counts. So you can see here that the Titanic passengers are more towards this age group. But then if you want to compare multiple different dimensions together, different, let's say, in this case is different cattle breeds. So a bar plot stacked upon another bar plot doesn't look very visually appealing. So we're moving to density plots. So for density plots, you can easily see here that for different cattle breeds, the butter fat percentage in the milk they produce, they tend to concentrate at different percentage points. So for example, this first breed here is about 2%, mostly towards 2%. So there's a highest concentration here. Then if you're talking about Jersey, say over here, it's more towards 5.5%, maybe 5.4. And there's a higher variance because you can see here it's more spread out. So like from one look, you can easily compare like where it's most concentrated at, and perhaps its variance also, and other statistical measures if you like. Yep. So again, we'll be passing the time to Madi. He'll be taking us through some density plots with the COVID dataset. Madi, on to you.
Yep. So don't worry, guys. After this, the sections will be really short. So just quickly, let us just look at a histogram, how it's plot. So we have got the Plotly Express method again. So Plotly Express allows you to quickly plot a histogram. So let us just take a look at how this particular plot looks like. So we have got the distribution of new daily cases that we have passed here. So we just needed, the x-axis, and then the count will automatically be generated. So, we are able to see a trend more focused on the first part of the chart here. Most of the time, the daily cases were actually between 0 to 99, as you can hover over and see. About 412 times over the past 1.5 years. It was around less than 100 cases, thanks to those quick stringent measures, right? But we have got this particular parameter here called n-bins. Let us just look at how this particular parameter helps you to change the plot. So for example, if you were to leave it to 5, so we would be able to see a full concentrated plot on the first part. This is because n-bins actually tells you the number of intervals to visualize the distribution with. So here we are actually hiding a lot of information because we are not able to see the range of how the histogram is being distributed. So now we have got this particular maximum number of plots as the number of cases 1,014 so it's around 1,500, right? So let us just like make it 15 n bins, and we would be able to see a better distribution. We will be able to see a small kind of curve that we have talked about earlier. The density is being distributed. And although there was no specific cases between 1200 and 1400, we are supposed to represent this area as well, because we have got a specific plot here which shows the number of cases, the highest cases, right? So which is, although it has happened a few times or once only, right, we cannot neglect the space that is happening here. So I'll leave nbins, you have to play with this, and of course there are fixed calculations. We'll not go into the math of this, but that is what distinguishes this from the other plots. As it will tell you, you have to determine how the distribution or the shape would look like based on the n bins. When you had 5, you were not really able to see any kind of a slope which can be seen here. Yeah. And next we will just look at a box plot. For this, we will be concatenating the Singapore data as well as the data of Malaysia. So we use plotly.express.box, and let us just look at what this plot does. And here we have actually seen the new cases in both Singapore and Malaysia. I think many of us would have worked with box plots from secondary school as well. You'll be able to have some important information like the maximum, as you can see here, and the upper fence, the upper quartile, the lower quartile, the median, and the minimum. And this particular color, as mentioned earlier, we are allocating this color to one of the data frames. So we have got SG and Malaysia, and Plotly will automatically assign the color to Singapore as well as Malaysia. But in Singapore, as the number of cases were actually not really big as compared to Malaysia, you are actually not able to see a box here, but although it's existent. So let us probably do an exercise which actually shows a better box plot compared to this. So I'll provide about 1 minute as well again. So let us just try to create the stringency index. So I'll explain what is stringency index after that. Let us just start the 1 minute now. Yep, so the time is up. So probably let me just get the code for this. So stringency index is basically all the COVID-19 measures that different countries have put together. So for example, as they might call it, circuit breaker or lockdowns on how, or the travel restrictions, the bans, and basically the mobility of people. So it's on a scale of 0 to 100, with 100 being the most strict. So some countries, like for example, New Zealand, I think has got really high stringency indexes for like 93. I think they really did not allow for any mobility of people into and out of their country. So let us just look at this particular plot. So we do not have to worry about concatenating it again, because we have got the Singapore and Malaysia plot. And here we pass the Y column as the stringency index, and color because we want to see it in different colors. And we provide a title to this, and let us just look at how this particular plot looks like. Here we have a better box plot representation, you are able to see a box for both Singapore and Malaysia, and you have got the important statistics like on minimum level we had a stringency of 25, and maximum we had like 82 as well. So we are able to compare between the stringency index over the days. So most of the time, we have this median, or in Malaysia we have 67, and in Singapore we have around 50. We were half open and half closed as well. So that is pretty much sums up this section. On to Edmund again. Thank you.
All right. Okay. Thank you, Madi. So we have done visualizing distribution. So a gentle reminder that the Slido is live. So if anyone has any questions regarding any of the content so far, please head over to our Slido and drop a question. Link is in the Zoom chat. So so we'll be moving on to our next objective for this workshop, which will be to visualize proportions. So we have already looked at amounts, distributions. Now we're going on to proportions. So proportions, what they do is they really emphasize fractions based on the whole unit. So if you think of proportions, you might think of, say, pie charts. And then there's certain bar charts that can also serve this function. So we'll be looking at them shortly. So this is the very familiar pie chart. We saw a whack example on the newspapers just now of the yes and no's being misrepresented. So yeah, these are pie charts. So it used to represent simple fractions. So it doesn't really emphasize on absolute values, but more of like just like a makeup from the proportions. So you can see here that on the right says the browser market share. Chrome easily can be seen that they have the highest slice of the pie. Yep, and Safari has the second largest one. So you can see these are the two top used browsers. And then not so common, but then side-by-side bars can be used to show proportions too. So you can see like a proportion of a market share from these 5 different companies over 3 different years. You can see that, like for example, in 2015, proportion of A is the lowest and E is the highest. Then as time progresses, we see the change in proportion of market share. Then by 2017, company A has overtaken company E. So you can see this trend going on here. Then one more is stacked bars. So you can see here between 2 different variables, women and men, you can see that there's a relative proportion between the 2 categories. So if you see like the composition of this country's parliament over time, you can see that there's a greater proportion. The proportion of women actually increases over this 15 years. Yeah, so it started with men having higher proportion. Then by 2015, women has a higher proportion. So it can be easily seen from this plot. And then if you're dealing with more than 2 categories, you look at stack density. So these are to visualize values that are not too straightforward. So you can see here the different categories of health. So there's poor, fair, good, and excellent. So you can see by like at age of 20, there's a higher proportion in like say good and excellent. You can reach up to 80+%. Then as people get older, the proportion of people in excellent and good health actually decreases to say about 55. And then the proportion of people in poor health actually increases from say almost 0 to, well, sizable about 10%. So you can see that from stack densities. So yes, we'll be moving back to the hands-on. Madi will take us through some of these plots based on the COVID data set. Madi, back to you.
Yep. Thank you, Edmund. So, this particular section, you have been seeing overlap like stack bars and side-by-side bars as well. It all depends on what you use the data to tell. For example, in the stack bars, we were actually showing absolute numbers of Singapore and Malaysia, but alternatively, you can convert it to a percentage and, out of 100%, how much of the COVID-19 cases is being contributed of each of the countries. So since that is all repetitive and it all depends on the manipulation of data, we will just look at pie charts for this particular code along. So let us put aside the COVID particular data and look at reproduction rate. So I'll just hit this to manipulate the data to get reproduction rate of countries with more than 3. And then let us use px.pie, will just give us pie chart. And for that, we would have to pass in the same data frame, which is manipulated above. And for the values, we will place the reproduction rate as seen in this column. And for the names, which would actually determine the colors, we'll pass in the location as well. These are actually slightly different from the normal XY charts that you have seen above. But the parameters, they are really self-explanatory through those official documentation. Let us look at how this particular pie chart looks like. No, we have this colorful spinning wheel. We have got different colors for each of the countries with a reproduction rate above 3. And you can hover over, as usual, to see what each of the quadrants means. But it's actually quite hard to look at this particular coloring and then refer back to the legend on the right, and then you come back. But let us just customize this to make it look better, so such that the text or the country lies inside. So we'll have this particular function called update traces, which is available with every single figure that we are generating. So we update traces where we place the text position inside, and then we'll have all the labels inside, which will provide information about the labels as well. So let us just hit this. And now it's actually more nicer to have the country together with the percentage inside. And probably let us we remove this particular legend here because we don't need it anymore. So now we have this particular function called figure.update layout. So update layout would update the whole plot as the whole plot, especially now we are just making the legend to false so that it disappears. So this would allow us to finalize the plot. And yes, that pretty much sums up this section. So for exercise, we won't be doing anything. We'll pass time back to admin, continue on for the next section. Yeah.
All right, thank you, Madi. So we're moving on to the next objective. So before we move on, just like to remind again that our Slido is live. If any questions, do drop a question there. Yeah, benefit for those who just joined. Okay, so now we're moving on to something a bit more complicated, but don't worry, this will be our last portion before our short break. So we'll be looking at visualizing among 2 or more quantitative variables. So just now we have been looking at plotting against continuous variables and some dimensions such as time or age. So now I'll be looking at plotting between different categories that do not need to be continuous or stuff of those nature. So we can talk about these. Can be think of like scatter plots or bubble charts. So if you're moving to scatter plots, you can see here that we can actually plot between, like, say, head length and body mass. It doesn't need to be age or time, it can be different variables in the data set. So you can see how 2 different variables actually maybe correlate with one another, or uncover some sort of relationship between the variables. So you can even add different dimensions based on the different colors of the dots. So you can see that in the scatter plot on the right, you can see like head length versus body mass of female birds and male birds. So maybe you can see here that male birds generally have a higher head length and body mass as compared to a female bird, because on average, they're more clustered towards top right for male birds as compared to a bit more to the bottom left for female birds. Yep. And then you can also see that it's kind of a straight line. If you want to, just draw one line here, you can see that, okay, sorry, that's not exactly the best fit line, but you can see here that there is some sort of relationship, some correlation between head length and body mass. So yeah, this is something scatter plots can help you uncover. So you can see 3 different variables here. Then something a bit more complex is correlograms. So for this here, you can see that you're not just limited to 2 different variables. Sorry, you can actually go. It's actually unlimited, because in this correlogram, you're actually plotting any desired number of categories and variables with one another. So you can see here in this famous Irish data set of flowers. So flowers can there'll be variables such as sepal width, length, petal width, and length. So you can see if you plot them, you can see that, oh, look at here, you can see here that petal length and petal width, they share some sort of correlation here. You can see you draw a best fit line here. So perhaps petal length, petal width, they are correlated. So from there you can explore and find out why. Then you can also see that they are separated by species. So the blue ones, they are Setosa species. Red, what they are this versicolor, and Virginica for green. So you can easily see from one glance variables, how they interact with one another. So you can ask from there, formulate hypotheses and different questions before exploring them further. Yeah, so that's the beauty of correlograms. But then, of course, they're a bit more complex for now, so do not worry about it. But then after this, Madi will take us through and we'll see a sample correlogram from the COVID data set. So yeah, Madi, back to you.
Yep, thank you, Edmund. Yep, so hang in there for this last section before our break. So for scatter plots, we have been using this particular px.scatter, and it's a really simple plot for us to tell how each two of these variables are related to each other. So we're just looking at stringency index over the days. And if you can't really see the scatter, you can actually like zoom in to see each of the dots are actually separated out. And because of the date range, it looks like there are straight lines. And we are now able to tell like how the stringency index have been changing over the days. So that is it for scatter plot. But let us just look at how a different type of scatter plot looks like using the GDP per capita and the life expectancy. Because we were looking at dates, probably that it will be more likely of trends or time series we'll be looking at later. But how about two other variables that we don't really have a natural intuition of how these can be related? So let us just manipulate the data here, and we'll be using the px.scatter, and we pass the x for GDP per capita and y as the life expectancy. And we'll just see the plot before I explain the other two parameters here. Okay, so now it is a different kind of scatter plot, probably known as bubble chart as well. So you can see them as bubbles. This occurs because of the size that we are providing. So the size of the population that we have in the data frame, that is what determines how big the circle would be. And we also have color for location, although it is quite irrelevant here because we don't have that many colors in Plotly available. And as you can see here, after a while, the color just gets repeated as we can't fit every single country. And from here, we would be able to see how the GDP per capita is related to the life expectancy. As you can see here, those with GDP per capita of close to 100K, right? People here in Switzerland, they're living really have a high life expectancy of like 83. Yeah, so we can see a natural correlation between GDP per capita as well as life expectancy. And yeah, that sums up the scatter plot. And as Edmund has mentioned earlier, we will be looking at correlogram as well. Correlogram is also known as Cato matrix. So if those who would like to know more about that, please take a look at those links embedded. And let us look at what this plot looks like. We have passed here specific dimensions of specific columns. So that is what, so we have only got about 4 variables here, and we see how each of them are related. And you can see how, for example, stringency index here relates to, for example, new cases. You can see probably it's not quite obvious if there is a necessary trend, because the cases just goes up and down. But probably in some other countries, probably not in Singapore, you'll be able to see how the stringency index or the new cases or the deaths match and how they relate to each other. Why this particular plot is quite important is because, many of the time we only plot one particular graph with 2 particular variables, for example, the stringency index against new cases. And you have to repeat it for example, the remaining plots that are here, which is quite tiring. And if you are able to see a necessary trend or particular trend using this correlogram, then you can actually plot out these two variables separately, and from there continue on your analysis to tell a story. So this correlogram immediately tells us how two variables are being interrelated using this particular scatter matrix. Yep. Although this is quite hard to understand for now, for true practice as well as true understanding of the individual plots, you'll be able to get a hang of the correlogram and you'll use it more often. Yeah. So that pretty much sums up this section. On to Edmund again. Thank you.
All right, okay, thank you so much. So now we'll be moving on to our break. So just another reminder that our Slido is live. Do join us on our Slido to ask questions. So just scan this QR code. So we'll be having a 5 minutes break. We can come back at about 11:25. Yeah, so enjoy your break, everybody.
baby, baby, I don't mind a little attitude with your sexy appeal, sexy, sexy. I wanna show you how you make me feel. I wanna get closer to you, psychedelic girl. I wanna show you how you make me feel. I wanna get closer to you, psychedelic girl. Don't care what you say, 'cause you're my love. Don't care what you do, 'cause you're enough. There can only be the two of us, only you. I wanna show you how you make me feel. I wanna get closer to you, psychedelic girl. I wanna show you how you make me feel. I wanna get closer to you, psychedelic girl.
Okay, hi everyone. It's 11:25. Yes, hope everyone had a nice break. All right, so okay, so just another reminder, our Slido is live. You can join us and pop some questions if you'd like. All right, so do not worry, the recording is accessible after this workshop. We'll be compiling everything and then we'll be sending it out to everybody. So this includes the slides and even the collab and collab stuff. So no worries, we'll be sending it after this. All right, so we got a question here for the Corellogram. Is average life expectancy, the average life expectancy seems to be constant in total death. What does this mean? Madi, you want to take this question? Yep, I'll pass the share to you.
Yeah, so basically for that, right, we have been seeing the life expectancy together with the total deaths, it's just a straight line. Basically, there is actually no correlation because, life expectancy, it is like a fixed amount and you don't really expect it to change with total deaths that actually just happen only during the COVID-19. The life expectancy have been calculated based on, throughout a number of years of data, but the total deaths don't necessarily like change the life expectancy of the country unless it is a really small country and actually there has been many deaths due to COVID-19, then it would significantly affect the life expectancy. Yeah, thank you. Pass to Edmund.
Okay, thanks. Okay, so yeah, we'll be moving on to our next objective for today, which will be to visualize time series. So this is something that you'll encounter very commonly in, say, your work environment or even in different modules, because in time series data, you can actually plot and you can see locate different trends and seasonality. So this will be very useful when you're like tracking past performances, and perhaps in the future, you would like to forecast into the future. We won't be talking about forecast today, but forecasting is a thing that you can read up, and then which will be used very commonly in the industry because projections and proposals are a very common thing. So yeah, okay, if we look at this plot on this airline passengers per month, you can see that number one, you can see a trend. So you can see actually an upward trend. Like between 1949 to 1959, you can see that the airline passengers actually increased because the people start to be more affluent and they can travel more, and there's more airports being built around this timing and more planes being rolled out, so airline passengers increase. So that's one trend that you can observe. Then another trend that we might want to ask is that why within like each pocket of time, you can see there's an up and down, up and down, up and down. Yes, we call this seasonality. So in seasonality, it's like, you know, in different times of the year, people may want to travel at different times of the year. So like if you're talking about Singapore, perhaps like in the June or December period, there are more people traveling. So there's that seasonal aspect to it. So maybe in this case, it's in December. So in like people like to travel for winter. So you can see that. So yeah, that's basically for time series. So Madi will take us through a time series for the COVID data set. Yep.
Yep. Thank you, Edmund. I'm sure like time series is not really new because from the start we have been looking at data against a time, which is the date. So I would say that this is actually something that we have been doing so far, but we are going to use line plots. So px.line would give us lines alternate. I mean, previously we have been seeing the different bar charts, right? So or scatter plots, when the scatter plots are actually joined, or if you see them very cluttered together, right, they will actually form a line. So using px.line, we look at the date range as well as total cases, and we all know about this particular trend. It is tending to rise over the date. And next up, we also just look at the color variable. So the color variable is decided based on the location. So we will have different colors for each of the lines. As you can see, it takes time to generate this plot because we are using the whole data frame. So we can see here the different countries and their trend of total deaths. And some countries are really like this particular country, Antigua, has got total deaths at a constant rate. So this is pretty much for time series. Probably we'll just look at one particular example, which will be for the total trend of deaths in Singapore and Malaysia. So I'll just give out 1 minute as well, as you can probably use the code above. Yeah. Yep. So I hope everyone has completed it because it's really easy, and we have got the DFSGML data frame that is readily available. So we just need to pass in the correct parameters. We just want to look at the total depths, and we're looking against time. And as usual, we have got the color as location, and we would see the title as total COVID deaths in Singapore as well as Malaysia. Yep. So let us plot this. And we have got this particular trend over time as compared to Malaysia. Singapore's death has been fairly constant. So you see like a flat line, although it rises by 1 or 2 per day. And in Malaysia, we've got a significant growth, which shows the number of deaths increasing at a really exponential rate. So that is it for the time series. As mentioned earlier, we have been looking at time series data from the start because we are pitching against date. Yeah. So catch you back at the next section of code along.
All right. Okay. Thank you, Madi. So we're moving on to our final plotting objective for today's workshop, which is to visualize geospatial data. So in my opinion, geospatial data is the coolest because the plots you create, they are very visually appealing and they'll make your like your dashboard stand out. So if you can look here, there are stuff like maps, choroplaths, cartographs, and even heat maps. So it's usually using like a certain projection of a plot of a map to showcase certain variables and certain dimensions. So these can be highlighted using colors, and intensity of colors do play a part here. So if you look here in the chloroplath map, this is a really good play of colors. So you can see here that, like, say, employment rate by state in the US. So if you can see this portion of this state over here has the highest unemployment rate by percentage. And perhaps if you look towards this area, there's less unemployment as compared. So you can see here a trend, perhaps, that different states do have different unemployment statistics at a certain at a first glance. So yeah, next will be a scattered geo map. So I'm sure most of you have seen this during these 2 years. These very common during COVID times because people like to track how COVID has affected the whole world. So at the start of the pandemic, you usually see like different parts of the world having different color intensities while the virus is still spreading. So you can see different areas were impacted by the virus, different intensities. So like, okay, for this specific example, we're talking about population. So if you look at, you know, countries with more of an yellow tone, they're more populated. Then dark with a grayer tone, they're less populated. So yeah, you can see this at a glance. All right, so Mario, take us through a hands-on for this, and you'll see some very visually appealing plots based on the COVID data set. Back to you.
Thank you to Edmund for showing mentioning about the teaser. Yep. So let us just first look at the choroplath map plot. So I've got trouble pronouncing this, but let us just look at, you know, the median age of people in every country. So we'll manipulate the data as usual. For the choroplath plot, right? No, we'll pass in the data frame as usual. When it comes to geospatial data, you know, it is very important to pass in the latitude and longitude, but sometimes it may not be available. So that is why they also mention about the ISO code. So we have the data frame which contains the ISO code, which is a universally recognized and accepted. That is why we don't really have to pass in the specific latitude and longitude. Plotly will take care of mapping it to the correct part of the world in the plot. And this particular projection would differentiate how our plot would look like. I'll just plot this first before we get into the details of what other parameters mean. So we have got a really cool 3D plot. You know, by just the similar lines of code, we have got a 3D plot where we'll be able to rotate, and we'll also be able to hover over as usual to look at the different values and intensities. And we have got this specific color scale of greens. You can customize it to others from the official documentation. There are several other palettes available, but we'll keep this for now. And this particular variable, the parameter here is important because, you know, this takes in the least and the most. So the median age here, we will take in, you have to see from the data frame what is the least median age for the country and the most. This may not be automatically calculated, so it is best that we actually customize this color range so that we will be able to get the difference in the concentrations in really detail. So you can see like the real dark, which is the top of the gradient, right? So we are able to note that they are close to this 49 that we have been placed here. I think there is a country that is 48. That is why I've placed that. I think it's Japan or something. Yeah. So this would allow us to customize and make the graph look better, because if you were to leave the concentration gradient to automatic, right, you know, sometimes you'll not be able to see the difference between the geo states that are side by side. Okay. Yeah. So just take note of that because you'll be using this for the exercise later. And next we have the scattered geo map plot. For this, we'll just look at the normal distribution of the population. And same as above, we're passing through the locations of the ISO code. And we will also look at the color of the locations. As mentioned earlier, we are running out of colors for all the countries in the world. And we have got this projection. We change it from the orthographic to the natural earth, which is like most of the maps that you see on a flat table. So you can actually scroll through from the left to right to see the other parts of the map as well. So this is how the projection determines how the map would look like. And lastly, we have the parameter of size population. So the population would actually determine how big the bubble looks like. So we have this fig.update traces, and we have the marker size, which we would like to increase to see some of the countries that are really small. So let us just look at how it will look like when you customize the marker size. Now you can actually see those countries that were actually really small, but since we are overwriting the marker size, right, you can see here that every single plot would look the same, because we are forcing it to be 15 and not be dependent on the size of the population. So at times, if you want the viewer to actually note what are the how big where all the smaller countries, right? If you want them to visualize it better, you have to do some kind of a calculation, for example, like doing logarithmic to make it look better, so that for example, if you have the original plot, we would be able to see those countries that were actually not visible to be have a better bubble size, like those Argentina here is barely visible. So these are things that you have to take note. Sometimes the original data would not allow us to tell the story as a whole, and it might hide details. So you have to have some data manipulation required. And lastly, you will just look at the map box density heat map. So this particular plot, we would be using a separate data set, as for this particular plot, right, density map box, we have to particularly provide the latitude and longitude. So we will be using an earthquake data set. Just let us plot it. And from this, we were able to see the distribution of the magnitude. So we know that earthquake happened at a certain magnitude from, like, for example, 5.5 to 9 here. And this color gradient is automatically generated as well. So we will be able to see how the distribution lies across the different parts of the world and what is the magnitude like. So for example, if it's really dark purple, earthquakes have happened, but in a lower scale, and those with the bright orange or yellow, they have happened at a really large scale. And Mapbox style is provided by Mapbox. So Mapbox is really a popular company in this geospatial world, where they provide different maps, latitude, longitude, and other map related data. And fortunately, they have provided some of the basic tiles here for free, although it's actually a paid service and you need like API to configure. But for Plotly Express, we have got some Mapbox plots available, and let us just change this tile to a dark mode. As programmers, we all like dark mode at the back, right? So let us just change this to a particular style called Kato Dark Matter, which is a particularly interesting style to look at because of its dark background. And now you'll be able to see a much better contrast between the colors. Yep. So these are the customizations that are available, and density map box specifically requires latitude and longitude. So that's why we have to go away from the COVID-19 data set. But for the exercise, let us just come back to the COVID-19 data set, and please use the choropleth and the projection of orthographic. So just give about 1 minute. We would have to calculate the percentage of population. So we have already calculated, use PERDF as the data frame required for this map plot. Yeah, so just provide around 1 minute as well. Yeah, so it's the interest of time, let us just quickly get into how the plot would look like. So as mentioned earlier, you have got the percentage DF, and you'll pass in the locations ISO code, and we have got this percentage, we have got this title and the projection as orthographic. For the range color, okay, this is particularly calculated using the maximum and the minimum mentioned in this DF. So you can try per DF dot max and minimum of this specific column, and then you'd be able to get the values that we are using now. So we have got the maximum of, like, for example, 20% of the population that is with COVID. So if I'm not wrong, it's actually United States. So yeah, that is how easily we can come up with a 3D plot. And this basically sums up the geospatial. You can do more with it, but yeah, that's the basics for now. I'll just quickly run through the animations as well as a quick dashboard that you can put together in Plotly. So no, it's quite hard to just look at, I mean, it's quite boring to just look at static plots or just images throughout. So Plotly allows you to actually come up with animations as well, really simple and quick ones without having to code your CSS or JavaScript for that. So we have got this particular data set inside the Plotly Express. So it's called Gapminder, and we'll pass in the usual parameters. But we have got this extra parameter called animation frame, which would determine the number of, which would determine how the trend would look like. So for example, I just play this plot here using this stop and play button, and you can see here how the relationship changes between GDP per capita and life expectancy over the years. And you can actually allow users to manipulate or go through the different date ranges using this slider. So this slider is determined by the year. As you can see here, it shows the different years. And the animation group country is what you see here on the legend, which is changing over the years. And the other data or parameters that we have mentioned would actually force you to fix the ranges so that, for example, in 1952, you only have got the maximum GDP on like 1,000, but then suddenly you have got like 100K over the years. So we have to fix this range so that the plot doesn't keep on getting cut and makes the animation as smooth as possible. So as the interest of time, I'll leave it to explore it yourself in the official docs. There are many examples of how this can be done. And I'll show a quick one using the bar chart as well. So the bar chart, we just play the animation. You can see the population have increased across the continents. And the same method as above, we will pass in the animation frame year and animation group as country. And we have got this slider feature available. Okay, that is pretty cool. But let us just put everything together in a small dashboard. As mentioned earlier, the advantage of Plotly is, we can couple together with Dash. So Dash is a low-code framework for building data apps, specifically in like dashboards or AI or ML apps. So you can take a look at how how it's being used in enterprises from the official documentations. And we have got the exercises, right? We have actually placed variable names in front of the plot. So Plotly has actually allowed us to store the plot, and we would use that to quickly have a small dashboard ready. So I'm using a simple template that is provided in Dash, which unites HTML as well as Python. So we have got this particular library that we would like to install, Jupyter Dash. So I need to quickly run this, and I have got to restart and run all, because this is a new library. As whenever you actually install a new library, there might be some issues. So it's good that you just quickly restart and run all. Don't worry. Meanwhile, we'll just take a look at the different. Yep. So meanwhile, we'll just take a look at the different apps that are being available in Plotly. Probably just give me a minute. Okay, so basically there's some problems with the notebooks, but as you have seen earlier, right? I have actually placed this code. We have commented out this, so you'll be able to see a nice plot when you actually comment out this particular 4 plots as a dashboard inline in your notebook. So probably I'll just try to fix this before the end of the session we'll just proceed on to the next section of Tableau in the interest of time. So probably when the dashboard is ready, I'll just show you. But yes, this is available and you can take a look at how the dash apps are made and how complicated they can be, or to really create the user interaction by just using code as well. Yep. Thank you. I'll pass the time back to Edmund. Yep.
Okay, thank you, Madi. Okay, so before we move on to Tableau, there's some 14 principles to take away from today. So of course, first is proportionality. When you're plotting a bar chart, please start from 0 so that we can have an accurate depiction of the proportionality. You can see here Hawaii is being depicted as very, very small proportion as compared to Honolulu, but in reality, they are not very much different. Yep. So then if you're going to use colors, if you're going to use them to represent different categories, try to use colors that have high contrast so they can be easily differentiated. Then if you're talking about values in a certain intensity format or certain values, so you can use them in different intensity, the colors in different intensity of the same scale, so that we can have a nicer effect on the viewer's eyes, so they can easily differentiate different intensity. Yep, when we're doing bar charts, don't just use lines because they'll be very ugly. Yeah, on the left is very ugly, so do the right one, put solid colors. Then if you're doing bar pie charts and stuff, try to not use 3D plots, because if you see on this one, graph A, 25% looks very, very big. It's being represented as larger than it actually is. So it actually skews the perception. So you can see from D, 25% is actually much smaller than 25% in A. So only use 3D plots when you need to. Yep, again, don't use these graphs look very cool, but then they're very difficult to read. So you get 3 dimensions, right? If I come at this point, where is this point exactly? Then the viewer needs to think, oh, it's here, here, and here. Then it takes a very long time to actually kind of find relationships in this kind of graphs. So try not to do it. Yep. All right, so we're passing the time to Shreya, who'll be taking us through a Tableau demo.
Okay, thank you, Edmund. So hi, everybody, I'm Shreya, and I'll be sharing more about Tableau, which is another platform for data visualization, very widely used in the industry, even by companies like Amazon and Unilever. So you might wonder, what sets Tableau apart from typical tools like Python? Why is it so widely used? That's actually because you need no coding background to be able to use Tableau, and it's really more or less code-free. So people in the industry often use Tableau Desktop, which is a paid version of Tableau that can cost up to $70 a month. Next slide, Edmund. Thank you. Yeah, can cost up to $70 a month as part of a large package of Tableau offerings. So this is quite a hefty sum. But the great thing about being an NUS student is that you're actually eligible for a 1-year free Tableau Desktop license. So you should have already received the guide to downloading Tableau Desktop. If you're not eligible for Tableau Desktop yet, or you already finished your 1-year license, you can continue by downloading Tableau Public as well, which is the free alternative. It has fewer features, but it still has some pretty great features. All right, next slide. So now I'll be starting to teach you how we're going to use Tableau Desktop to create a detailed and interactive dashboard for us to learn about our COVID-19 data around the world. So don't worry about using it yourself right now or following along right now. You can just sit back and relax while I demonstrate how Tableau works. Yeah, a demo will be sent to you later on how to make a dashboard. So let's get started. Okay, so Tableau actually runs in the form of workbooks, so to which you can connect your data and you can build different sheets and dashboards or visualizations from. So we can actually connect to data that's both locally stored, like Excel files and stuff, or we can also connect to data that's in a server. So right now I've already connected to my locally stored data in a CSV file, and I put it in a notebook that I called demo version. So let me just open that up. Yeah. All right, so you can actually add more data frames if you want, and you can join them together based on common columns, but today I'm not going to touch on that. So this is what our data frame looks like. Tableau sort of attempts to identify each variable's type in advance. So it identifies these locations as strings, dates as date-time format, and some of these variables like total cases as numeric. So let's get started on visualizing some of our data by opening up a new sheet over here. Yeah, so this is what a Tableau sheet looks like, in which we can make one visualization. So we have our variables stored on the left over here, split into dimensions in blue and measures in green. So what are dimensions and measures? Dimensions are just items that Tableau has decided are categorical. So these are measures, while measures are those that it believes are numerical. So things like continent are dimensions, things like your GDP per capita are considered measures. So you might wonder, why is positive rate or number of ICU patients considered a dimension? That's actually because the data set has a lot of nulls in itself. So the sheer number of nulls likely made Tableau decide that they are just dimensions. So beside our variables, we have our shelves, which we use to adjust our visualization. So we have our filter shelf, our row shelf, our column shelf, our pages cut, and our marks cut. So I like to sort of think of the row shelf as like our y-axis and our column shelf as something like our x-axis. So bear with me, I'm going to go a bit quickly because we're running out of time, but yeah. Okay, so I'll give you a very simple demonstration of how these cards work. So let's say I take location as a variable, and I will drag it over to the row shelf, which I mentioned is like our x-axis, right? Sorry, our y-axis. So of course, there aren't any entries in the table yet, but it just says an arbitrary ABC, while it layers the locations by rows in the form of a table. So this is where our measures come in. They fill up these ABCs over here. So let's say I want to know how life expectancy varies across different locations. So I'll just grab life expectancy from the measures, and I will drag it over to columns. And this is where you might be a bit confused as well, because wow, we have a bar chart, but why is the life expectancy going up to like 45,000? So that's actually because Tableau has a way of aggregating its measures when it puts them into columns or rows. So it will just take the sum of life expectancy of across time of each location. So since there are many, many entries of life expectancy per location, it just makes sense to take the median or mean entry as the aggregated entry per location. So how do we do that? We'll just click on our measure here in the column. I'll just navigate over to measure, and I will just change it to median. And just like that, we have a more reasonable bar chart with life expectancies ranging between the 40s to the 80s or the 90s. So one more thing you might realize, there are a lot of null values, right? So it says like, for example, Africa has a 0 life expectancy, which obviously doesn't make any sense. It's just because we have a lot of null values. So what we're going to do is we're just going to filter out our nulls just like that. We'll click 13 nulls, we filter data. And yeah, now we're roughly able to see the life expectancies of different countries. But it might also be useful to know the exact life expectancies of each location. So this is where our marks cut comes in. You see our marks cut over here. So all we have to do is drag our life expectancy variable again. We drag it from our variables on the side, not from columns over here. And we will drag it over to label. And just like that, we have our labels. I'll have to change the aggregation back to median. And yeah, now we have more or less accurate labels. So the purpose of this marks cut is just to add more details like colors and labels to our visualization. And yeah, that's really all it takes to make a very simple bar graph. If you want, you can even change the representation using the marks feature. So I can navigate to this thing over here, and I can just change it to a circle instead. So just like that, I have a dot plot instead of a bar chart. It's really that simple to use Tableau. All right, so now that we've done a very simple one, I'm going to teach you how to make something a bit more complicated, which is a box and whisker plot. Yeah, so you might remember that a box and whisker plot is just a means of comparing distributions of multiple categorical variables. So I'm going to make a box and whisker plot comparing the distribution of stringency indexes of different locations. So to do that, I'm just going to drag my stringency index variable. Let me find it. Yes, I'm just going to drag it over to rows. And it gives us a very large bar that goes up to 5,000K, which that's because it's been aggregated and everything was added together. So we're going to want to look at the individual range of stringency indexes over time. So I'm going to unaggregate it. So what I'm going to do is I'm going to go to analysis. I'm going to go to aggregate measures. I'm just going to uncheck that. And yeah, now we have our stringency indexes of every single data point ever all put together in one massive one massive column. So what we're going to do is we're going to modify our visualization to a box and whisker plot using this show me icon. So this show me icon is essentially how we navigate between different types of visualizations. So for now, I'm going to choose a box and whisker plot. Yeah, and just like that, we have one box plot of various stringency indexes across time. So of course, it's time to add location in as our y-axis, because actually what we want to do is we want to compare different stringency indexes, right? Yeah, so my personal opinion is that this box plot is really way too large. Like, for example, if I want to compare Afghanistan to Bhutan, like it's so far apart that I can't even tell what the difference is. So what I'm going to do is we're going to choose a subset of locations using this filters card over here. So all you do is you drag location over to filter. And then I'll select the items that I'm interested in. So let's say I'm interested in Singapore. United. And let's say United States. Okay, I'll apply. I'll press OK. And just like that, I have a much clearer box plot that shows me the distributions of different countries. So Singapore seems to have the lowest variance in stringency and is apparently the least stringent, while India has the largest variance and is the most stringent. All right, so there's a lot of interesting stuff we can learn from here. Now I'll teach you how to make one more very interesting plot that we all love to make, which is a geographic plot. Yes, so what we're going to do is we're going to make a world map that documents total percentage of population in every country that has or has had COVID. So I made a new sheet. So in order to do this, we're going to redefine our location variable. So right now, our location variable is a string, so it can't be registered as geographic just yet. As you may remember, it just showed me a table of every single location. So what I'm going to do is I'm going to change it to a geographic variable. Very simply, all I have to do is navigate over here, go to geographic role, and change it to a country/region. And just like that, you see the variable has changed to a geographic variable. Yeah, so what I'm going to do is I'm going to drag it over to my marks card, and I'm going to just put it over here. Yes, and just like that, we have our map visualization automatically created just like that. So we'll notice that our columns and our rows have become the longitude and the latitude respectively, just like our Y and our X axis. So now we want a measure of our total percentage of population in every country that has or has had COVID. Yeah, so we have every country that has or has had COVID. So one thing you might realize is we don't have such a variable in our data set. So we're going to do something new, which is create a calculated field. So this is something like what you do in pandas, where you take entries across a row in different columns and you put them together to make a calculation. So in my case, I'm going to divide the number of new cases by the population per country. So I'm just going to go to my variable called new cases. I'm going to click over here. I'm going to create a calculated field. Yes. Okay, and what I'm going to do is I'm going to create a field that just takes new cases divided by population. And it's really as simple as that. I'm going to rename it to new cases by population. And okay, yes, and just like that, we have a new variable right over here. So what I want to do is I want to populate my map using this new variable as a measure. So I'm just going to drag it over to my marks card. I'm going to put it under color because I want it to differentiate different countries, but different countries, new cases by population variable by color. So I'm going to put it down over here. Okay. Yes, and you'll see that it aggregates the cases by population by summing them together, which is correct because it's just taking the total cases by the population of the country. Yeah, so just like that, we have a really beautiful map. You can see that countries like United States have quite a high rate of COVID, like 0.1% of their population has had or currently has COVID. Maybe Australia has a much lower rate, things like that. So there's really a lot we can learn using this visualization. Yeah, so now that we have done up a few visualizations, we'd like to deploy them into a dashboard. So we just have to click on this icon to create a new dashboard. Yeah, so I'm not going to go through how to create a dashboard step by step in the interest of time, and also because it takes a bit of time to move all the figures around. Instead, what I'm going to do is I'm going to show you a dashboard that I've already deployed. So let me show it to you right now. Okay, so this is a dashboard that I recently completed. So it puts together two of the visualizations we did. Give me a moment, it seems to be reloading. Okay, and it's back. So I actually changed the color palettes a little bit to represent, okay, so loading a bit. Yeah, but I changed the color palettes to make it more geographical in nature. I changed the colors of my box plots a little bit as well. So the links to check them out are also in the chat if you want to check them out on your own. I've even added a few additional features. I added a date filter over here, so you can see how the stringency index looks at different times. Sorry, what I did was I added a date filter. So for example, I can do this. It will just load a bit and you can see the range of stringency index in this shorter time period. I can even add more locations. So let's say I want to know about Argentina. So I can just check Argentina. And just like that, Argentina is now also in our visualization. Apparently it has quite a high stringency index as well. Yeah, so that's all for Tableau. Hope you've enjoyed how interactive and user-friendly it is. I'll pass my time back to Edmund now.
All right, I think Madi has something to show us for the dashboard. Yep.
Yeah, so sorry guys. So just now each collab was just loading. So if you have followed these steps of installing the Jupyter Dash library as well, just comment out and just click on runtime and restart run all. Okay, and then just comment out these variable names. So basically these are the figures that we have stored earlier on. Okay, and then after it is running, right? So we're just running this inline. We have this COVID-19 dashboard. It's not as excellent as the one that Shreya showed just now. It's the basic one. Basically, these are the plots that we have plotted them individually above. So we have got around 4 exercises that we did, right? So these are the 4 plots. And you also can add all those user interactions, but that happens together with Dash, and we'll take it another time. So yeah, thanks for allowing me to share, and hope you have made a simple dashboard using Plotly as well. Thank you.
All right, okay, thank you, Madi, for the dashboard. Okay, so yeah, we have come to the end of the workshop, so sorry for overrunning. So thank you for staying, for those who are still here. Okay, so here are references for today, and then materials for today. Don't worry, we'll be sending all of these out. So yeah, so just some publicity. So yeah, please, if you enjoy what we did today and enjoy what we do based on introduction, yeah, please feel free to join SDS or NUS Hackers. So as for SDS, these are the links. We'll be sending them out also. So Chun Young, anything to say for hackers?
Yeah, so for the past few weeks, if you have enjoyed the content that we do feel free to join our telechat. Yep, for more interesting events. There are still other events like Hacker Tools and Friday Hack. So yeah, feel free to join us if you think this is something that you find interesting.
Okay, thank you. So yeah, so if you enjoyed today's survey, or if any tips for us to improve our future surveys, please do fill up this feedback form. Your opinion is very valued. Yeah, we're still learning. We're all students also, so we are all in this learning journey together. So yeah, please let us know. And then also, have Chun anything to say for this intro to JS?
Yes. So I think before that, I have a few admin instructions. So for those who have signed up using our Google form, please remember to use the correct email address, and also please sign up only once. So for example, if you use NUS Sync, please do not sign up using the Google form, and vice versa. And for those of you who have received the NUS, for the Hackerschool email, and you received it in your junk folder, please remember to mark it as a not junk, so that it will improve the email reputation of NUS hackers. Yeah. Then also, last but not least, if there are some of you who haven't received the email, I know a few of you have some difficulties with that. Remember to join our NUS Hackers telechat as a fail-safe, as a safety net or a backup. Yep. So I know there are a few of you who didn't receive our email, although we have sent it. So I think we can all do our part to sort of improve the email reputation of NUS Hackers, so that everyone can receive the email that we send out. Okay. Yeah. So for intro to JS, it will be after recess week. So it will be just covering modern JS, So it's just a very short introduction of JavaScript that's used today, and in the following weeks we will build on that by exploring CSS and HTML, as well as looking at React. So if you're interested in web development, then you can join us. Where can we view the recording? It will be uploaded on YouTube later at NUS Hackers YouTube channel. Okay.
Okay, yeah, thank you, Chen Yong. So now, if you'd like to leave, if you have to leave for lunch, please do. Yeah, we'll be staying about 5 more minutes to answer the remaining questions on Slido. So, yep, let me change my share. Okay. Okay, yeah, so if any more questions, yeah, please do. We can spend the next 4 to 5 minutes until about 12:15, 12:16 to answer these questions. Yep, recording will be accessible after this. Okay, so if we answer this, okay, if you want to export it, say for presentation, unfortunately, can't really export it to a PowerPoint, like to use it very interactively. But alternatively, what you can do is you can just show the notebook itself, or you can perhaps screen record a video and convert it to a GIF, or you can just put the video itself on the presentation. Yep. Okay. Sorry. Okay, wait. What's this question here? Yep. So there's a question for Shreya. Might have missed what Shreya said, but what files does Tableau read?
Yeah, sorry if I didn't explain that properly. So I actually read the exact same file that we've been using for the entire Python collab notebook. Yeah, so it's the same COVID-19 data.
Okay, yep, same data. So yeah, animations, projections can export as a video if you want it for your presentation. For reports wise, yeah, unfortunately, it only supports the interactions on IPython notebook. So if whoever you're viewing a report has to open the IPython notebook and Jupyter as well, yeah, on any other software.
Yeah, alternatively, if you choose to use Tableau, you can do it on, so you can just export your visualization to Tableau Public from Tableau Desktop, and then anybody can view it, just as you viewed mine just now. Yeah.
Yeah. Okay, do we have any other questions? If I covered this. Yeah, I've plot against timeline bar chart. Basically, yeah, it's just different ways to achieve the same outcome. But for the each has different like specialties. Like for line plots, it's really to show trends. For bar plots, you might want to view proportions as well. Yeah. So it's just basically what objectives you want to achieve.
I have a very great example for the line plot and bar chart. Maybe I can send the link here. So back to the COVID data, the COVID-19 Singapore's dashboard. Yeah, if you look at number of cases, you actually can choose between bar and line on the top right-hand corner. The top right-hand of the, yeah. If you see line is very messy, but bar would make it more intuitive, especially if you want to look at the number of active cases in Singapore. So hope that gives you an example of why we choose bar instead of line or line instead of bar.
Yep. Okay, are we only restricted to only one of these attributes, high, low, volume with time? Okay, if their scales are similar, perhaps you can overlay the different plots. Yeah. Okay, if you have an interactive one, you can actually like on Tableau, you can tick the check boxes to show which ones you want to display. If you like to like compare between highs and the high price and the low price, if you overlay them, then you can see the trends also. Yep.
Just make sure you don't mess up your scale. So like you use one single scale but two different variables.
Okay, stringency index will explain. I think this one was answered just now. Presentation slides be shared. Yep. Okay, this one was answered. Okay, same answer. Okay, yep. Are there any other final questions? If not, we can close in a minute.
Yeah, we can also give place in the Zoom chat as well.
Okay, dashboard, the difference between Tableau and the one made in Colab. Okay, so for Colab, it's more of like you want to deploy onto your websites. So for because it runs on Dash, so it's a whole interface that can be you can deploy it lah. So it's you can upload it to a website or something and have it publicly available. So for Tableau wise, it's all hosted on the Tableau servers. There's a whole community of people on Tableau public, and dashboards are being shared there. So it's just depends on your usage. So if you want to host it on Tableau and host it on your own, say, server or whichever location. Yeah, but Tableau uses very little code. Colab uses a lot of code. Yeah, so that's nothing to consider. Okay, last final call for questions. Okay, how many people we have left? 17.
Quite
okay.
a lot of people still staying around.
Yeah, it's about 17 yeah, yes. Okay, then if there are no final questions, I think we can end here. Yep. Okay. So thank you everyone for coming. So we hope that you have enjoyed and see you all at the next workshops. Okay. Goodbye.
Okay, goodbye.
Goodbye, everyone.